Writing a recursive equation for arithmetic sequences. Now, recursive is based on the term before. So it's not like our explicit for any n. We actually base it on the term before. So we have an arithmetic sequence. We're adding 5 every time. We can see that in the table. We can see that in the linear graph. And now we want to take a look at how do we calculate the next term given the term before. So remember, n is the place of the term, like the first, second, third. So with n equals 1, then t of 1 is equal to negative 2. And the t of n is the actual term in that place, so the negative 2 in this case. So when n equals 1, we know t of 1 is equal to negative 2. When n equals 2, t of 2 is equal to 3. So if I know t of 1, all I have to do is add 5 to get to t of 2. So I can get to that next term just by adding 5. So then we can see those terms here, we see them here, and we can see them here. So if I take t of 2, all I have to do is take t of 1, whatever t of 1 is, add 5, and then I get what t of 2 is. So in this case, 3. T of 4, if I wanted to get t of 4, all I have to do is take t of 3, add 5, and I get to t of 4. So anytime I want the next term, if I know the term before, all I have to do in this case is to add 5. So if I want to get to the next term, the one past t of n, that would be t of n plus 1. So if I want to get to t of n plus 1, all I have to do is take the term before, and the term before t of n plus 1 is t of n, and then add 5. So in this case, my 4 right here, I would take t of 3, so my n would be 3, t of n plus 1 would be t of 4, and then I would add 5 and I get to that t of 4. So this right here describes a sequence in terms of the term before. So the only problem with this is sort of general. It doesn't tell us where we're starting. In fact, this sequence, 1, 6, 11, and 16, actually does the same thing that this tells me here. So I take the term before, I add 5, I get to the next term. So I can see this follows the same pattern, but it's not the sequence we're talking about. And so I need one other piece of information all the time when I write recursive equations. I need to know where it's starting, or at least one term in there, so I can figure out where it's starting. And so to include in my recursive equation, I need that t of 1 equals negative 2. Really any term here. So t of 1 equals negative 2. This together gives me my recursive equation. So it has to have two parts.